Good day, guys. Alright, so in this video, I want to introduce to you two things. Number one is the centripetal acceleration, and the second thing is the centripetal force. Right? So, um, as per Newton's second law, when we have some form of acceleration, we will have some form of force. So when we talk about centripetal force, we will start with centripetal acceleration. So let's get into it. Let's ask the question, what is centripetal acceleration? Well, centripetal acceleration is actually the acceleration of a body traversing in a circular path, right? Okay, so but then again, you ask me, um, the speed doesn't change. Where should this acceleration come from? Well, even though the speed doesn't change, but the velocity change, all right? And the velocity change in the sense that its direction change. Now, the magnitude of that velocity doesn't change. However, the direction change. All right. So we'll consider this in detail in a bit. All right. So the next question you might ask me is, what is the direction of the centripetal acceleration? Right. Because it is a vector, then what is the direction? Well, if you have a body moving in a circular path, right? The centripetal acceleration will be pointed towards the middle or the center of the circular path or the circle. All right, that's the direction. And then how then can we calculate the magnitude of the quantity? All right, so let's consider this. So here what we have, a circular path, right? So say you have time t1, where you have the object at position r1, right? And then its velocity vector is going to be the green one over there, v1. And then sometime later, what you have is at position r2, and it will have velocity v2, right? So I'm going to focus on these two positions, right? And of course, there's a difference between r1 and r2, which is what we're going to call delta r, right? Okay, so let's zoom in on that. Okay, so if you extract them out like so, what you will find is that there are isosceles isosceles triangles with congruent angles. All right. So what can we say then? Okay, since there's both isosceles triangle, we can work out a ratio between them. Okay, so let's just define a few things. Delta r to be the difference between r2 and r1, right? And because these are small angles, right? As you know in mathematics, the arc length is equals to the r, right, the radius, times or multiplied with the angle between them, which is which is generally in radians, right? So S equals to r theta. But because theta is so small for small angles, our arc length delta S is going to be approximately the same as our delta r, right? Okay, so what else do we need to say? Well, we can say that because the velocity, the magnitude of the velocity is the same, right? Then we can say that the magnitude of v1 and the magnitude of v2 is v. Let's just simplify that. Okay, and then because it's a circle, right? Our r1 and r2 will be the same as well. Now, again, going back to my point where they are both congruent triangles, we can take their ratios to be delta v over v is going to be the same as delta S over R, right? And the reason why it's delta S here is to make the mathematics much simpler later on. But in essence, because delta S and delta R are the same, this is actually delta R over R, alright? Okay, so we will be working from here in the next slide. Let me just get into it. Okay, so we have the ratio delta V over V equals to delta S over R, right? So what we do is we multiply both sides with V, okay? We multiply both sides with V so that it gets rid of the one on the left hand side and it adds an R value to the right hand side. And what we can do from here, because as we know, acceleration is the rate of change of velocity with time, we will divide both sides with t, okay? we will divide both sides with t. So in short, we are dividing both sides with 1. Okay, and then we can rearrange this the right hand side to take the form of this. So we have the v here, a v and r here, right? And then we have the s and t, which is the displacement, and t over here. Okay, so this by definition is just v, so, right? So this is just v, and then we have v times v over r, which is just v squared over r. And it is this quantity that we define to be centripetal acceleration. Okay, and as per Newton's law, F equals to ma, we can find the centripetal force, and that is how you calculate, you calculate the magnitude of this centripetal acceleration. All right, so v squared over r, that's all. And again, just to remind you that from here to here, you use Newton's second law, which is F equals to ma. Okay, so as just like Newton's laws, right, the acceleration is going to be the same direction as the force. So if the centripetal acceleration is towards the center of the circle, right, the circular path, then the force will be in that same direction as well. Okay, so to summarize, centripetal acceleration stems from the change in direction. It doesn't come from the change in the magnitude of the velocity, right? Because the magnitude of the velocity is just speed. It does not change. The direction, however, changes. And because this direction change, we have centripetal acceleration. And because we have centripetal acceleration, therefore a force will come about, and we call that force to be centripetal force. Okay, so that is it for this video. Okay, so in the next video we will be studying 3 cases, right? 3 cases of uniform circular motion. Number 1, this horizontal uniform circular motion. The second one is the vertical, right? So probably the best way to describe it is along the y-axis. And then the last one would be the conical pendulum. All right, so I'll see you in the next video. Thank you very much.